Uh, in this video, I'm going to continue from this slide onwards. You have learned C programming language to some extent. There you have studied about structures. Okay, in a structure, we had only fields. When you learn Java programming language, okay, then you have learnt about classes. Within the class, we have not only attributes, we have methods as well. Okay, so when it comes to C sharp, okay, then the class concept is realized in two ways. Unlike Java, we have the class concept as well, the classes as well as structures. Okay, so I have discussed about classes, and then I'm going to discuss about structures. Okay, structures represent a combination of fields with data, look like classes but are value types. Their content is stored in the stack, transmitted by value, destroyed when go out of scope. Okay, so now when you create an object, let's say we have a class called student. This is a class. Okay, so when we now this is a reference variable. Okay, student S, we declare a reference variable, and when we consider random access memory, there we have a part called stack and a part called heap. Okay, so this reference variable is created on the stack. Okay, then we invoke the new operator, and then the default constructor. Okay, so in this situation, object will be created. An object will be created on the heap memory. Okay, then memory location of this object is stored in this variable S. Okay, so actually objects, we say they are reference types, because we refer the object, and objects are created on the heap memory. In contrast to that, when we consider about structures, when we create a structure, they are always created on the stack, not on the heap. Okay, that means a structure will behave something like this. Okay, in the same way X behaves, a structure will behave. Okay, so that's why we say that structures are value types, and their content is stored in the stack, transmitted by value, not by reference. Okay, so I hope you have some understanding about pass by value and pass by reference. So a structure will be passed by value. destroyed when go out of scope. Okay, those things are clear to you. Behavior of a structure is similar to a primitive data type like this. Okay, so however, classes are reference type and are placed in the dynamic memory. That means when we create an object, it is created on the stack, on the heap, and reference variable will be created on the stack. Then the memory location of the object is stored in the reference variable. Their creation and destruction is slower. When we consider objects, okay, creation and destruction of objects are slower compared to structures. Therefore, when we use C# programming language, if we worry about the speed of execution of the code, then it's better we use structures rather than using classes. Okay, and now let's move to the next slide. This is an example. So this is a structure. The name is point. We can use the struct keyword, and here we have two fields. Public is the access modifier, X and Y. Two fields are there. Point structure. Okay. Then another structure is, name of the structure is color, and here byte. Byte is also a data type, that is an integer data type. Okay, so here we have three fields, and if you consider the square structure, there we have four fields, and here this field actually we have created using this structure. Okay, now if you consider this particular line, public point location. Point is a structure. Okay, therefore it behaves as value types. Okay, that means in text the behavior of this variable is similar how the variable x behaves, similar to how variable x behaves. Okay, so that's why we call structures are value types. And here int size, color, here also we have used this structure and created the variable. Okay, likewise another variable. Okay, then we should know now, as I have mentioned, in C#, the class concept can be realized in two ways, using classes and structures. Then how can you decide whether we use classes or structures for a particular problem? Then use structures to make your type behave as a primitive type. If you use structures, then those structures behaves like this, primitive types. Okay, and if you create many instances and after that you free them in a cycle. Okay, that means if you want to create many instances, then using structures is better, because creation and destruction of objects are slower compared to structures. Therefore it's better we use structures when we create many instances, and after that then we free them. Okay, so where we should not use structures, when you often transmit your instances as method parameters. That means as method parameters, if you pass structures, since structures are value types, all the fields in a structure will be copied. Okay, so pass by value is happening there. Therefore this passing process takes lot of time. It will make a copy. Okay, so if you have some understanding about pass by value and pass by reference, then you will understand this clearly. In Java you have already learned this concept, and structures are passed by value. Therefore always when we pass a structure, a copy will be created. If the structure has many fields, all the fields should be copied and a new structure should be created. Okay, therefore it's not suitable if you pass often. If you pass structures as parameters, then it's not suitable to use structures. We can use this class concept instead, because then only references will be passed and we are not going to copy the objects, and in that way we can save execution time. And the other thing is, if you use collections without generics, too much boxing and unboxing, this point that is beyond the scope of our syllabus, and therefore I'm not going to discuss that. You have to just keep it in your memory. Okay, now let's discuss about delegates and events. Now I have mentioned that in object oriented programming with Java, you have only learned that within a class we had attributes and methods. Okay, but when it comes to C#, we have fields. Fields means actually fields resemble attributes. Not only fields, then we have methods. Okay, many other members are there. Delegates and events are such members. Okay, so now let's discuss about delegates and events. What are delegates? If you consider delegates, they are reference types. Okay, I hope now you understand the meaning. Describe the signature of a given method. A delegate will describe signature of a particular method. Okay, number and types of parameters, the number of parameters and also their corresponding types, and also the return type of the method. Those are the things described by a delegate. Their values are methods. If you consider a delegate is actually, it describes the signature of a particular method. Then values of a delegate are methods. Okay, then you will understand when I discuss about examples. These methods correspond to the signature of the delegate. Okay, these methods, that means values of the delegate, correspond to the signature of the delegate. Okay, now delegates are roughly similar to function pointers in C and C++. I'm not sure whether you have learnt about function pointers in C anyway, but that is not a problem. If you haven't learned, that will not be a problem to understand this. Contain a strongly typed pointer to a method. Okay, they can point to both static or instance methods. That means if you create a delegate, now methods can be divided into two categories: instance methods and class methods. Class methods means static methods. Okay, so to both methods we can point a particular delegate used to perform callbacks. Okay, so that's also beyond the scope of this course, so we are not going to talk about callbacks. Now let's discuss about delegates using an example. Now definitely you will understand. Okay, very simple thing. Now here, this is how we should declare a delegate. That means let's use the access modifier public. Okay, access modifier. Then we use the delegate keyword, delegate void simple delegate. Simple delegate string param. Okay, now this one, this is how we declare a particular delegate, and this is a keyword, and this one, this is the return type. Return type of the methods we point from our delegate, and this is the name we have given we have given to our delegate. Any name you can give. Okay, and this is the parameter list. In this particular situation we have one parameter and its type is string. Okay, you can include any number of parameters with preferred types. Okay, now this one, within this class, now we have included a method. Okay, so this method actually return type is void. In this method return type is void. This is actually a static method, that means a class method. Its return type is void, and this is the name. It has one parameter and its type is string. Okay, so using this delegate we can point this method. Okay, that is the idea. A delegate means we have a return, we specify a return type and also the list of parameters. Okay, that's how we create a delegate. Such a delegate can point to a method that has the same return type and the same parameter list. Okay, so now here inside this method we display I was called by a delegate and I got parameter param. Okay, the purpose of this one is something like this. You have used in C, you have learnt this. Okay, the purpose of this one is this. Okay, and now inside the main method, now you can see simple delegate inside the main method. Okay, simple delegate. Okay, delegate, simple delegate. Now we use any name actually you can give here. Okay, this one, simple delegate, new simple delegate, simple delegate test function, within parenthesis, since I do not have enough space, I write it here, test function. We have to write everything in a single line, but since I do not have enough space, I write it like this. And now we have created the reference. Okay, now this our simple delegate, this one signature of this, actually here return type is same as the return type of our test function method, and the parameter list is exactly same as the parameter list of our text function method. Therefore, if we create a reference like this, now this can point to our test function method. Okay, therefore when we use this simple delegate, okay, now it refers our test function method. Therefore when we pass test, when we pass a parameter like this actually, this simple delegate actually refers test function method. Therefore this test string will be passed to this parameter, and these two lines will be displayed. Okay, that's what happens here. Now I think the concept of delegate is clear to you. Actually, a delegate can point to a method. Okay, that is the idea. Then we talk about anonymous methods. Anonymous means methods without names. Okay, using delegates we can create methods without names. Okay, now we are sometimes forced to create a class or a method just for the sake of using a delegate. Okay, in order to use a delegate we create a class or a method. The code involved is often relatively short and simple. If we want to create a class or a method, the code inside that particular method or a class is very short and simple. In that case we can create it as an anonymous method rather than giving a name for that class or a method. Okay, anonymous methods let you define and name and nameless method called by a delegate. Less coding will be there, improved code readability will be there if you use this particular feature. Okay, now here using delegates, this is the standard way. Inside this class we have created we have declared delegate void sum delegate string str. Here return type is void and we have one parameter, its type is string. Therefore this sum delegate, if you create a reference from some delegate, Okay, so it can point to methods in which return type is void, and also the parameter list uh, has one parameter, its type is string. Okay, now here we have a method void sum method string str. Okay, like that. Now this method return type is void and it has one parameter and its type is string. Therefore if you create a reference from some delegate, it can point to this method. Okay, here what we have done is that we create a reference from some delegate, some delegate dlg new some delegate within parentheses we have to specify the method some method. Okay, some method. Now here this dlg points to some method. Okay, therefore we use dlg and we pass hello. In this situation actually this method will be invoked. Okay, this method will be invoked. Then let's move to the next slide. The same thing can be accomplished by using an anonymous method. That means now you can understand that this method has only a single line of code. That means a short and simple code is there. Therefore it's unnecessary we create we give a name to such a method there. That is why the anonymous method concept is important. Now look at here, the same thing can be accomplished by using an anonymous method. That means here delegate void some delegate string str, then invoke method. There what we do is instead of creating a method called some method, we can directly do it like this. Okay, uh, some delegate dlg, there we use the delegate keyword here, and then string str. Okay, then here we specify the body of the method. Okay, console dot write line. Now here to include this body we did not create a method with a name. Instead we simply use delegate keyword and then we assign that method to this reference. So we can simply invoke it like this. Okay, now in this way we can achieve less coding. Okay, that is also important when you write complex programs. Okay, Then let's move to the next slide. Then we talk about events. Now we have discussed about delegates. Now let's talk about events. In component oriented programming, the components send events to their owner to notify them when something happens. Okay, when we press a button either on the keyboard or mouse, a particular event is raised. That means mouse click, left mouse click is an event. Pressing a particular key on the keyboard, that is an event. Okay, the object which causes an event is called event sender. The object that causes a particular event, we call that the event sender. The object which receives an event is called event receiver. In order to be able to receive an event, the event receivers must first subscribe for the event. Okay, now events in .NET framework. In the component model of .NET framework, delegates and events provide mechanism for subscription to an event, sending an event, receiving an event. Okay, now here events in C# are special instances of delegates declared by the C# keyword event. Okay, actually events means they are special instances of delegates. This is an example. Here we use event keyword. From event handler we create click. Okay, like that we can create an event. The C# compiler automatically defines two operators. Okay, so this one to subscribe for an event, this one to unsubscribe from an event. There are no other allowed operations. That means if you create an object from a button, that means to that event button we can subscribe this particular. That means when button is clicked, this one will be executed. Okay, something like that. Now let's discuss about delegates versus events versus delegates. Events are not the same as member fields of type delegate, and these two are different. Okay, event is processed by a delegate. Usually when we process an event, we have to do it by a delegate. Events can be members of an interface, unlike delegates. In an interface we can include events as members, but we cannot include delegates as members. Calling of an event can only be done in the class it is defined in. Once we have included an event in a particular class, we can invoke it only within the class itself. From outside it's not possible. By default the access to the event is synchronized. Events are thread safe. I don't know whether you have learned about threading. Okay, system.event handler delegate, if you consider that, defines a reference to a callback method which handles event. Okay, so event handler delegate. Okay, no additional information is sent. This is the delegate used in many occasions internally in .NET, ASP.NET and Windows Forms. We use this system.event handler delegate. The event args class is base class with no information about the event. Sometimes delegates derive from it. Okay, so these are some information about events. Okay. Now this is an example. So in the button class we have click. Okay, so button, we can click the button. Okay, that is an event. We can got focus, another event. Text changed, another event. Now inside this button test class we have private static void button underscore click. Okay, so here we display this one, and now we create an object from button class. To the click event we subscribe this method. That means once you click the button, this line will be displayed. Okay, that is the meaning of subscribing to a particular event. Okay, that's a little bit about events. Okay, so now let's discuss about interfaces and abstract classes in C#. If you consider interfaces, now I hope you have already learnt about interfaces in Java. Describe a group of methods, operations, properties and events. Okay, using an interface we can describe a group of methods, properties as well as events, can be implemented by given class or structure. Okay, it can be implemented by a given class or structure. Define only the methods prototypes. That means only the method signatures are included in an interface. No concrete implementation will be included in an interface. Can be used to define abstract data types. Okay, we can create abstract data types using interfaces. Cannot be instantiated. Members do not have scope modifier, and by default the scope is public. We cannot create objects from any interface. Okay, in Java you have learned these things. Here I just remind, members do not have scope modifier, and by default the scope is public. That means we do not have to specify the scope. We do not have to use access modifiers for the members of an interface. By default they will be public. Okay, now this is an example for an interface. Usually when we give names for the interfaces, we start them from capital I, then another capital letter person. Okay, I student, something like that. This I is important in order to later this will help us to distinguish interfaces. Okay, that is why we use we start any interface from capital I. Okay, and now here string name, string name, that is a property. We include only get set keywords. Okay, date time only get set, only get. Okay, likewise this is how we create an interface. So this is another example. We create I-shape interface. There we only include the method prototype, return type, name of the method and its parameter list. Okay, here return type, method name, parameter list. Here its parameter list is empty. and iMovable class, iMovable interface, their return type is void. This is the name of the method and the parameter list. iResizable, yes, this is one particular method. Another method is there here, method overloading, okay, with the same name but with different parameter list. I hope you have learned those things in object oriented programming in Java. Resize by X, resize by Y. Likewise, we can include a set of method signatures inside an interface. Interface implementation. Classes and structures can implement one or many interfaces. That means I have taught you that in C#, multiple inheritance is not allowed. That means if you consider one particular class, for this class there can exist at most one superclass. That means if you consider one particular class in C# programming language, either it does not have a superclass or it has exactly one superclass, and that means multiple inheritance is not available in C#. In Java also multiple inheritance is not available, but if you consider C++ programming language, there C++ supports multiple inheritance, but in C# and Java, since we do not have multiple inheritance, we can do the same thing using interfaces as an alternative way. So if you consider one particular class, it can implement any number of interfaces. Okay, interface realization must implement all its methods. Once we have realized from one particular interface, we have to implement all the methods available in that interface within our class. If some method do not have implementation, the class or structure have to be declared as an abstract. Once we have realized from a particular interface, then one rule is we have to implement all the method signatures available. We have to provide implementations to all the method prototypes available in that interface. If we are unable to do that, we have to make such methods abstract within our class. Okay, then this is an example. So here we have realized from we have implemented these two interfaces in this class. Therefore all the method prototypes within these two interfaces should be implemented in our class. Now let's see I shape, their set position, calculate surface, move. Now three methods are here. All three methods we have provided the implementation. Set position here, this this implementation, and here this implementation, and here this implementation. Okay, now I hope the concept is clear to you. Now what about abstract classes? Okay, interfaces and abstract classes, these two concepts actually facilitate abstraction. There are four fundamentals in object oriented programming. If you have learnt about object oriented programming in Java, now you know abstraction is one of them. In order to achieve abstraction, we can either use interfaces or abstract classes. Abstract class is a method abstract method is a method without implementation. Okay, that means if you are not going to implement a particular method, we can keep its body empty. Okay, but we have to put the abstract keyword. Let's discuss it by an example later. Left empty to be implemented by descendant classes. That means you inside the class, okay, inside the class you can include a method. You can include a method without body. Okay, there we have to use abstract keyword to indicate that we are not going to include a body. Then you feel that what's the purpose of including such a method? The purpose is the children of this particular class can provide the body for that particular method. Okay, so now left empty to be implemented by descendant classes. Descendant classes means subclasses. Okay, when a class contains at least one abstract method, it is called abstract class. That means in a class, if we include at least one particular abstract method in a class, if we have at least one particular abstract method, we must make the class also abstract. Otherwise, we will encounter a compilation error. Okay. When a class contains at least one abstract method, it is called abstract class. Mix between class and interface. Okay, an abstract class actually it is a mixture between class and interface. Inheritors are obligated to implement their abstract methods. Inheritors means subclasses or children of the class cannot be directly instantiated. That means we cannot create objects from abstract classes. Okay, so now let's move to the next slide. Here we implement iShape and iMovable interfaces. If you consider iShape and iMovable, there are three methods: set position, calculate surface, move. Okay, and now here set position we have implemented, move we have implemented, but we are not going to implement calculate surface method. Therefore, we must make it abstract. If we are not going to provide the body to a particular method, then we have to make it abstract. This can be done using abstract keyword, and once we have included an abstract method, okay, if we have included at least one abstract method at least one abstract method in a particular class, then definitely we must make the class abstract. Okay, therefore here we must use abstract keyword, otherwise you will have a compile time error. Okay, now let's discuss about cohesion and coupling. Cohesion describes how closely all the routings in a class or all the code in a routing supports a central purpose. That means if you consider one particular class, it has members, no? Those members should support support the central purpose. Okay, that is the meaning of cohesion. And also cohesion must be strong in object oriented programming. Classes must contain related functionality and aim for single purpose. Okay, the members should be strongly related and they should aim a single purpose. Cohesion is a useful tool for managing complexity. Okay, well-defined abstractions keep cohesion strong. Now let's see, this is an example for good cohesion. If you consider hard disk, CD-ROM, floppy, they have a central purpose. But if you consider something like that, they do not have a central purpose. Okay, this is an example for a strong cohesion. That means if you consider math class, that is an inbuilt class, math class, this class contains methods related to mathematics. That means sine, cos. Likewise, we have methods. This is an example how we can use these methods. Okay, bad cohesion is something like this. Class magic that has all these methods. In a class, if you consider these print documents, send email, calculate distance between points, okay, then that class does not focus to a central purpose. Therefore, we have bad cohesion. This is another example. Then the other concept is coupling. Coupling describes how tightly a class or routine is related to other classes or routines. Coupling must be kept loose. Modules must depend little on each other. That means if you consider two separate classes, student, course, these two classes should be loosely coupled. Okay, that means modules must depend little on each other. Okay, all classes and routines must have small, direct, visible and flexible relations to other classes and routines. One module must be easily used by other modules. The purpose is then let's say we want to edit one particular module. Then if we have coded it as a loosely coupled one, then it will be easier for us to modify. Okay, that's the purpose of loose coupling. Now this is the example for loose coupling. Easily replace old hard disk drive, easily place this to another motherboard. Okay, so now okay, this is an example for loose coupling. That means this one loosely coupled with other components, and this one tight coupling. In this situation we have the inbuilt video card, therefore it is tightly coupled with other components, and it's very difficult to replace it. Okay, that is the idea. Then let's move to the next slide. Loose coupling example. That means if you consider report printer, two classes. Here we load from file and save to file. Okay, and now here we print printer. Now these routings are loosely coupled, therefore we can simply create my report an object and store it in my report reference variable. Then from this we can load from file. Okay, and then print it. Okay, so this is an example for loose coupling. This is an example for tight coupling. We have math params class. In this class we access math params dot operand here, this one. Okay, so this way is not recommended, because if you want to modify this particular class, since we have tightly coupled, it will be difficult for us to modify. Therefore tight coupling is not recommended. Always we have to have strong cohesion and loose coupling. Spaghetti code, combination of bad cohesion and tight coupling. This is an example. We have both bad cohesion and tight coupling. Okay, then let's move to the next slide. Here we discuss about inheritance. So now I have assumed that you have learned object oriented programming with Java. Then you have learned about 4 fundamentals in object oriented programming. So inheritance is one of them. And I briefly remind those things using C# programming language. Inheritance is the ability of a class to implicitly gain all members from another class. That means if you inherit from a class, and also in C# multiple inheritance is not available, and if you inherit from a particular class, all the members available in this class will be available to this class. Okay, so that is the idea of inheritance. And now inheritance is fundamental concept in OOP. The class whose methods are inherited is called base or parent class. This class we use the term base or parent class, and then this one we call the derived class or child class. Okay, then inheritance establishes and is a relationship between classes. Here now this is our class B A. Okay, A is B. Here we establish is a relationship. A is B. Okay, so I hope you easily understand these things since you have learned this concept using Java. Okay, now all class members are inherited. That means if you have one particular class from another class, if we inherit, all the class members will be inherited. All the class members will be inherited, fields, methods, properties, etc. In C#, classes could be inherited. The structures in C# could not be inherited. Okay, inheritance can be applied only for classes. Inheritance allows creating deep inheritance hierarchies. That means we can inherit. Likewise, deep hierarchies we can create without any problem in C#. In .NET there is no multiple inheritance. Now you know what is multiple inheritance, except when implementing interfaces. Even though for a given class there can exist at most one superclass. That is why we say that multiple inheritance is not available in C#. However, we can implement any number of interfaces. Okay. How to define inheritance? We must specify the name of the base class after the name of the derived. Now this is our base class. In Java we did something like this: circle extends shape. Okay, and instead of extends keyword, here we use colon. Okay, that is how we symbolizes inheritance in C#. In the constructor of the derived class, we use the keyword base to invoke the constructor of the base class. Okay, now in order to access the constructor of the base class, we can use the base keyword. Now this is an example. We have a class called mammal. There we have a field. Then this is a constructor. This is a property. This is a method. Now dog, we inherit from mammal class. Okay. We inherit, and here we have is a relationship. Dog is a mammal. Okay, and now here we include an additional field, breed. Now dog inherits age field. Okay, age field due to inheritance, and here we include a constructor, and using the base keyword we access the constructor of the super class. Okay, that means this constructor, there we pass the age, and then we can set a value to age attribute. Okay, age field, and here we include another property and another method. Okay, now here in this example we create 5 years old mammal. In this way we can create, then we can invoke sleep method like this, and here 3 years old bulldog in this way. Then we can invoke sleep method, age, and likewise you can easily understand this. I'm not going to discuss in detail. You have already learned these concepts in Java. Then let's discuss about polymorphism. Polymorphism is a fundamental concept in OOP. The ability to handle the objects of a specific class as instances of its parent class and to call abstract functionality. That is the idea of polymorphism. Polymorphism allows creating hierarchies with more valuable logical structure, allowing invoking abstract functionality without caring how and where it is implemented. Okay. Then polymorphism is usually implemented through virtual methods, abstract methods, methods from an interface. So, okay, those are the three ways. In C#, to override virtual method, the keyword override is used. C# allows hiding virtual methods in derived classes by the keyword new. Now you can see here in class person, we have print name method, then trainer class inherits from person class. Here we have used virtual keyword. Here we use override keyword in order to override the inherited method. Okay. Here also we use override keyword in order to override the inherited method. Now here we create an array of persons. Now here person, from the person class we inherit from we inherit trainer and student. Therefore in person references we can store memory locations of trainer and student objects as well. Okay, so here we create an array. Okay, there we have in one particular in first now we create an array. In this array we stores the memory location of the person object. Here we store the memory location of trainer object, and here we store the memory location of student object. Then we use for each loop person p in persons console.write line p. Okay, so in that way we can access each member. Okay, so here it should be okay. So if you have any questions, so that is the end of this particular video, and thank you for watching.